This is Duane F. Melvin. The date is June 29th, 2020. And I want to present my design, and I'm calling it now the Air Knife. This is a 10 millimeter foam thickness, 10 millimeter throughout. So this thickness here is, that we're looking at right there, is 10 millimeters. And the entire plane is 10 millimeters, including the wings. And you can see there is a bevel in the center of the wing that comes up approximately 3/4 of an inch from the leading edge and goes down to the center. And I have beveled that off with sandpaper. This is the Depron-like foam, which comes from Hobby King, is where I bought it from. Very close to Depron. It really works well and sands well. So I have discovered the MAC here, and I've used the distance using the center of this plane, because you can see the bottom is a total airfoil. There is absolutely nothing on the bottom of this plane. I wanted to make sure I kept the bottom pristine and flat. So you get a very good picture of it there. Not a single feature. So I'm considering this whole bottom plane, whole bottom wing, to be a wing, to be a lifting surface. So when we do that, we start the MAC back here. We start to measure it. We're going to go from here up to about right here by this triangle here. And when we do that, we position our MAC about right here where my finger is. Now, if we take 1/3 of that distance, so let's divide it into thirds and move it up from the MAC, we come up with a CG, which I have marked here with this little dot. You can see that. That little dot, that's the CG. Now, the plane is slightly nose heavy with a 2200 milliampere hour E-flite battery, and I'll show that right now. When I pick it up on what I'm saying the CG should be, it does fall forward. It falls forward. The actual CG measured on this plane now is a little further forward than that, about right here. So we're pretty close on the CG, and it's a little to the nose heavy side, which is good. Now I have taken these connectors and separated them from their body. And this goes to the load side, or the ESC side right here. And it's just easier to do this than having to plug in both of them at once. The only thing you have to make sure of now is that you get your polarity right. Look, at that red indeed goes to the battery red, and black goes to the battery black. But I find this to be better. I just like it better than having to plug the whole connector in at once. And it is something that you have to be careful of as far as the polarity when you do this. And it also reduces some slight bit of weight. It all adds up. And this connector is gone, you see. The one that would normally be here has been removed. And actually, I didn't remove it. I actually built these wires with these connectors here, soldered them on just without the blue jacket plug. So moving on up here, I'm going to show something about the structure of this airplane. Now, when you build a plane like this, the easiest way to see if you've got problems is to lift the nose right here and try to see what bends on the plane. Now, when I first lifted this up, I noted that this part right here bent right in here. So in other words, it was flexing like that right at this aluminum rod. And it's because I don't have anything in the center. I don't have any kind of support in the center. It's just this 10 millimeter foam. It's very weak. So I decided to put these pieces on right here, which capture underneath some. You see, there's some balsa under there, balsa strips that go underneath to about right there. You can kind of see it, and it's glued tightly there. So this right here, these pieces perform the function of keeping this from flexing. So it makes it rigid. And then also, it's hard to see, but I have a carbon fiber rod. You can see it here. It's a very thick rod. I believe it's like a 3/8 inch rod, almost a 1/4 of an inch. And that rod goes right straight through, and it ends here. But it really goes through this piece, right on up to here, and you can see the tip of it right there. If you look closely, I think I'm pointing it out there. That's the tip of that rod that goes from there to the front. So we've taken care of that. And then back here, we have some pieces of balsa that the servos are glued on to give it good rigidity here, which is not that much force here. But right here is a real problem area. Right in here, where there's almost no material, no white material. And so I put in some nice square rod carbon fiber. Took care of that right away. So there is now absolutely no flexing at all. When you lift this up, there is no flexing. Okay, so the back end, let's go to that and talk about that. I've got, this is something I just started doing. I had not seen it before. I'm sure someone has done it before. But I bought these, you know, the Velcro strips that are little square strips. And they're already pre-cut into squares. Well, I'm just cutting the nylon part, not the fuzzy part, but the nylon part. And using that nylon part to as a hinge. So this is the industrial strength Velcro. And let me try to show this better. So here's the typical Velcro sheet that you get, okay? And one of these is the fuzzy part, you know, and one of these is the loop part. So the loop one is the one I'm using, which is this. It has the loops in it, not the fuzz. So there's the fuzzy one, but I'm using the loop one right there. And those are going right in place, right here, being glued down as the hinges for my Elevon control. Now let me turn it over, and anybody that's done any modeling knows about this, but I'll just show it. I had to cut out a 45-degree angle, so you can see it right there. You see that cutout, see that? So I have chopped out, using a knife at an angle, that whole section so that these are free to move back and forth. You know, they have, in other words, let's see if I can show this. They have the ability to flex now. It's kind of hard to show and hold the camera at the same time. See if I can do it. There we go. So the flex, I'm not going to be able to do it because of the servos. Let's see if I can show it this way. So we're able to get a really good flex on this. And let me just move the servo and show that. See, so now we're completely flexed down with maximum travel. Let me show the bottom now, and you see how there's that cutout there that leaves room for that to happen. You see, here's the non-deflected one, right? And then here's the deflected one. You see that we've cut out that space right there so that when this thing does deflect, say right here, it's deflected and it's able to do that. Okay? Let's go right on here. Just back up. Something like that. A couple more features here just to show quickly. I used a very thin steel, could have been carbon fiber, but I didn't have any thin enough, so I wanted the thinnest possible vertical here, so I wouldn't interfere with the airflow across this vertical fin. So I used a piece of very small piano wire and glued it on each side, and you can see it's on both sides there for support of the vertical during flight, you know, when we get the vibrations and movements there to give it some support. Everything else is pretty straightforward. I do have massive connections here for this, even though this is just a nylon part right here, very weak, but I have supported it with a piece of plywood and then glued it and punched it down into the foam and glued it with some with hot glue. And then over here we've got the turnbuckle, which I actually didn't use. I twisted all these together. Actually, the way I built this was I turned the radio on, get the servos at 0, In other words, adjust the radio and the dual rates and the sub trim to exactly 0 on left and right elevon, and then you put these in, loosen the screws, and adjust these at the servo right there, and you adjust those so they're identical. And by that I mean they are identical in their angle up. So this servo here will be identical to this servo here. They're not wonkered, you know. They're exactly the same position. And then what you can do is glue on this piece last. So I put everything on. Put this screw in there, put this in there, and I'm holding this in my hand like this, literally. And with the radio on, holding the servos in place, I punch this down into the surface here, making sure that this edge right here, this edge here, is not being violated, so we can have, you know, good movement there. And that's literally how I line these up exactly. And you'll note that the hinge point, which is right here, is exactly vertical straight up to that point there. Now let me show that. If you don't do that, you will get differential movements. So see how this is lined up just with the hinge. I'm trying to show that now. What I'm trying to show you is that this bolt is directly above the hinge line. If you see that, it's very important. You can see it maybe better here. See that? How the bolt is exactly in line with that hinge. It's not further back or further up. And what this does, it will give you no differential. Now what differential is these surfaces are moving like this. Well, differential means that you've got the up going higher than the down. So you'd end up with something that went like this. You know what I'm saying? Like this, where you'd have more deflection on one side than the other. And you don't want that. You want a nice room, big range, and equal range for the most part, to start off with anyway. Now let's talk about this EDF. This is a brushless motor. It's a 3500 RPM per volt, if you can see that. Let's get this into the light. I'm sorry about that. See, I've got a serious light up here. There's my light. It's an LED light, so I shouldn't be messing around with this, right? Let's get it under the light for you folks to see it. Okay, so this is the, you kind of see it there, 3500 RPM per volt, if it'll focus. Trying to get it to focus for you. I'm having a little trouble here. Well, hopefully you can see that. And so this is a 6-blade fan. 6 blades there on the EDF. Let's see it this way better maybe. And of course it's a 3-phase brushless motor, sensorless, powered by this 2200 3-cell pack lithium poly, a 60 amp speed control. I found these speed controls to be very good. There's the brand. I'll show you that brand. I mean to tell you now, I have blown up several motors, fried these motors, and this speed control continues to operate. It is absolutely protected very, very well. It has good current limiting apparently, or it would have blown up during those events. So I can get a nice picture of that for you. So that's the speed control that I really am enjoying now. Hey, what else here? Well, I'm using Savox servos, and I don't quite really remember the specifications right now, but they're way overkill for this plane, which is always good. And right down in here, it's hard to see, but let me show you. This little gizmo right here, let me point to it with the pen. This gizmo right there with the 2 capacitors and the circuit board right here, that is a switching power supply that takes the place of the BEC. So I'm not using the BEC, and what that means is I simply don't have the red wire connected from the receiver to the ESC. I have opened that red wire. So in the signal path I'm talking about, in the actual PWM throttle output wire that goes into the to the ESC, I have removed the red wire. And then in its place, I have plugged in another connector that comes from this switching power supply that gives me my 5 volts. And actually I have it set for 6 volts. And so in other words, I'm not using the battery eliminator circuit in here at all. I'm using this switching power supply, and it keeps it a little cooler. This thing heats up a little bit with 3 cells, and this is a really nice little unit here made by ITT Corporation. And I've been using that now in several models, right up to a giant scale airplane, and bought a couple of those for use. Really nice. I believe these will work up to 14 cells or some really massive input of cells should you want to go that direction. Here, of course, we don't need that. We've got 3 cells. So just in general here, I guess I'd like to say that this plane has a wing loading here of 14 ounces per square foot, and should fly well. It's not going to be it's not going to be a floater trainer, but it's going to be able to fly, gentle flights with the nose up like this and do some hairier stuff pretty easily, I think. And then it's going to really be very speedy with these cut off areas on the wing, the sharpened edges of everything on this plane, and the thinness of this, only 10 millimeter thick wings. This thing should go well over 100 miles an hour. I'm expecting. So that's really it. I think I've covered basically kind of the building of this. One last thing here. I did have to put these wingtips on because these are actually glued, because the sheet of foam that I started with was only this wide, as from here to here. So I had to add some tips. Well, that's it. There it is. I feel like it's a pretty amazing plane. Now, I've been 17 minutes here into this video, but I feel like it's worthy to show this. This plane has more than a 1-to-1 thrust to weight ratio. Now, what does that mean? Well, it means that this thrust that is made by the reaction of this force is greater than the plane weighs. And so if that's true, when a person holds the plane up like this in their hand, when they hold it and they throttle the throttle up, it should float in their hand. It should handle the weight. And then when they throttle it up more, if it has greater than a 1-to-1 thrust to weight ratio, it will actually pull the person's arm up. It will actually fly your arm up. So I'm going to demonstrate that exactly, case in point, right now. Let me get my radio. Bear with me, the screen's going to go black for just a second. And now I've got my radio here. Bear with me just a moment. And we're going to plug this thing in. Okay, so let's bring you back into reality here. Here's my 12X radio. And now what I'm going to do is I'm going to plug in these connectors right here. Now I can't hold the camera and do that at the same time, so forgive me, I'm going to black you out again here. Make sure we get the polarity correct, black to black, red to red, of course. Very important. All right, we're plugged up. Let me show that. We hear the 3 beeps indicating that we have 3 cells. We got a little blinking light. We got a solid light now on our receiver. A little LED glowing for showing that we have 6 volts from the output of the switching power supply. And we should have movements here on the back. Let me show that. Look at the very back right there while I do this, and we see movements. Yep, see the movements. We have movements up and down. And we have our aileron movements there. Okay. Let's see if we've got a little bit of throttle here. I'm going to take the throttle up now. Oh yes. Now, I'm going to hold this plane. Now let me see if I can get the camera position. This is going to be the tricky part. I think I can. Let's position this camera so it sits up for you. And we can show this rather simply here, I believe. I can just keep the camera up with something. Forgive me, I'm trying to prop up the camera right now. There we go. Now I'm going to come up here and I'm going to show what I just mentioned about thrust to weight ratio. I'm going to hold the plane fairly at the top here. Make sure I'm in the picture. Let's get that right in the picture there, okay? And we're going to hold the plane up and we're going to throttle this thing up. So here we go. We're now going to throttle it up. Now I'm going to throttle it until my hand begins to float. See, right now I still feel weight. I'm going to throttle up some more. Okay, beginning to get lighter. Now you can see right there, that is actually weightless. Let me show that. Go up even higher and show how it lifts my arm up because it's more than 1-to-1 thrust to weight ratio. Here we go. All right, here's full throttle. Let's take it back down now. So what I was trying to demonstrate by allowing it to process around my arm there, my hand, you noted there was a lot of forces. So that's one of the disadvantages of a light foamy plane with little wings, is you noted that as I was holding it, it was spinning like this. And the reason it's spinning is because the action-reaction law, which states that for every reaction there's an equal and opposite reaction, and so that's what's happening there. So that's one of the things when you launch one of these planes you can really get yourself in trouble with. You never want to have, you know, full throttle. You want to come up just enough throttle to kind of almost fly the plane, maybe almost half throttle, and you want to toss it really steeply, almost vertically. You want to just toss that thing, and you don't want to let it grab on your fingers. You want to make sure that you get your hand away really quickly. That's the important thing, because you don't want to drag it over with your hand, and you want to just gently let it go, almost straight up, and then you know, then the trick is to grab the throttle and the sticks and force the throttle forward and fly the hell out of the airplane in order to keep it from crashing. So that's my next endeavor. There it is. Very proud of this plane. My invention, the air knife. Thanks for watching.